2 calcium. What happened here with, I guess I kind of overlooked it, but chlorine, again, see, we were talking about the 100% isotopes, 100%, and then when it got to the chlorine was the split. I guess my little highlight disappeared there, that's why it's missing. Another alpha up, past the argon, from chlorine is split, potassium has a split. This is a magic number coming up there, the 20 neutrons. So the chlorine is stable because it's got the magic number 20 neutrons. Potassium with the 20 neutrons, 39 isotope. So that split, you'll see these series. When we look at this in one piece, which is too big to show right now, you'll see that. Okay, we're going to go back to my ribose here because I want you to see how this came to be. It's going to let me in here. Let's make it bigger. What's it going to do? So, uracil, we give it a blue color. Okay, I'm going to stand in front here. Give him a little mohawk. Okay, this is a boy. Single-membered ring. How many hydrogen bonds? 2. It's got a proton on the nitrogen, electron pair on the oxygen. It's going to double bond to the A, adenine. So adenine gets ruby ribose. The ribose is a 5-membered sugar ring. This is the back of her hair. She's got the curly red hair, so see, she's backwards now because this strand is going down, this strand's going up. So they're complementary. The hydrogen bonds between these, 2. Down here we're going to see there's 3. So they're either picking or kicking the phosphoflowers. Back here, this girl's got the blonde hair. Call her Rhonda ribose. This dude's shaving his head. This is the back of his head. Guanine, so we can call him Randy ribose. So boy, girl, 3 bonds with the hydrogen bond. This again in the middle, nitrogen to nitrogen. This is, if you learn this, it's got everything in it. From a 1-membered ring, 2-membered rings. 2 hydrogen bond, 3 hydrogen bond. What makes a hydrogen bond? See, I'm calling it a hydrogen bond. I prefer to call it a proton bond. The proton bond between electron pairs. So one is already holding the proton, but here you got a nitrogen to nitrogen with a proton bond in between it. This, it's a miracle. Life is a miracle. Let's see what else we'll have here for your enjoyment. This is the star chart that we wanted. We got to back up just a bit here. Is it all going to fit in there? See, it's too small. So, this is what the sky, if you learn to look at a sky map, this is the Milky Way. This is what they call the equator. We want the plane of the ecliptic. And I went to a place once, and I'll never forget, the guy was going on, something broke, and the lady's like, little teenage girl, what about astrology? And the guy says, oh, that's total nonsense. Astrology, that's just a bunch of waste of time. Blah, 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 blah. The girl sat there with her feelings hurt, her boyfriend looking at her like she was an idiot. Astrology, don't you know that's a bunch of girls? Well, look at this. All the zodiac, all the constellations that happen to be in your signs or whatever, fall in the plane of the ecliptic, which means the sun follows the plane of the ecliptic. All the planets follow the plane of the ecliptic. So you don't find Jupiter being in, say, Hercules. The planets don't go into those constellations. The planets follow the same path as the sun, which follows the same path as the zodiac signs. So this equator here, when I see it going through Aquila, That's not what we want. We want the plane of the ecliptic, which doesn't seem to be listed. Okay, here we go. It's a little less. See the dotted line here? So nobody ever taught me how to read a star map. You know, you get them, you go out there, you hold them up. Some are made to be held down, some are made to be held up. How do you line it up? Remember where the sun set. Where the sun set, there's going to be a zodiac constellation in that realm, okay? And what's interesting is when they say, okay, I'm a Capricorn. So in January, when it's my birthday, I go out and I'm like, where's Capricorn? Well, when you're born, that constellation is behind the sun. So it's kind of like the opposite. And we're actually one sign off. So what's really interesting is when the sun sets, the constellation of your birthday that should be behind the sun is actually the first constellation you'll see. So Capricorn really isn't that bright a one, but Sagittarius, if your birthday, all my families mostly was Sagittarius. So in December, your birthday's in December, you go out, where's Sagittarius? As soon as the sun sets, just go up a little bit from where that sun set and you're going to see Sagittarius. And that's a good one because it looks more like a teapot, I think, than some archer or some guy with a half-horse body running around. So when you see Sagittarius, the teapot, another thing to remember is that teapot is pouring scalding water on the scorpion's tail. So right in between the teapot and the scorpion's tail, you're going to find the Milky Way. Okay? Now you can see these in the summer. See how this looks like a teapot? Well, right at the tip of the teapot is where the scorpion's tail goes. And the scorpion's a good one because you'll see it. It goes on the horizon like it's a curly tail. When it goes up, you're going to see a red star that's like the scorpion's heart. So these are the two that are easy to see. The teapot, they're usually low in the horizon so when the sun sets, look kind of to the south if you're up where we are in North America. You look, you're going to see a teapot, you're going to see the scorpion's tail, plain as day. If you're in a nice dark place, you're going to see the Milky Way in between it. And you can see the Milky Way. You can live in the city, you'll see the Milky Way. So our star chart here for August. We're going to need to zoom out a little bit. If this will let us. It's too much. So we're going to zoom a little bit more. So what I want to know is where the planets are. When you look here, you're going to see Jupiter and Neptune. Jupiter and Neptune here. Jupiter's bright. Can't miss it. Now the thing that I've been saying is if you go out with your digital camera, zoom in on Jupiter, you're going to see what are called the Galilean moons. These moons will look like stars because they're shiny. Phew, they just show up on your screen. If you've got a good zoom on it, okay? You'll look, you'll have 3 on one side, 1 on the other. 6 hours later, you'll have 2 on one side, 2 on the other. One will disappear behind it. This is what fascinated Galileo. They call them the Galilean moons. 4 of them are really bright, okay? I didn't see them until I was 42 years old. I went out and bought a cheap little telescope. I went out and looked, Jupiter. These things look like stars because they were really shiny and bright in the background. So any digital camera, if you zoom in, the Galilean moons will show up. So right now, if you remember the teapot, behind it a little bit is where Jupiter's going to be. Jupiter's bright as can be. The moon last month was so close to Jupiter for one day, I thought it was going to, they call it occultation when it actually goes behind it and disappears. So again, in about 3 more weeks, it's going to happen that Jupiter and the moon are going to be real close together. So when everybody goes out and goes, hey, what star is that? You can act like an Einstein and go, it's not a star, it's Jupiter. Jupiter and Venus are the 2 stars that are the brightest. Saturn gets kind of bright, but Saturn is just as far away from Jupiter on the other side as Jupiter is from us. So it's way out there. And right now the rings of Saturn are so even that if you look, it's just going to look pretty boring. You can't even see the rings of Saturn.